welcome to another WJEC A level physics question. This is question 4 from January 2010's PH4 paper. It's a question on the first law of thermodynamics, which is nowadays in Unit 3. So we've got a gas undergoing a thermodynamic cycle ABCDA as shown on the diagram. And the first part of the question asks us to state the meanings of each term. So we've got to learn these very, very carefully. We always define each of the terms here in terms of them being positive. So delta U, generally an accepted answer is a change of internal energy, but a better answer is the increase in internal energy of the gas. Could use the word system instead of gas. Q is heat flow, but again we define it in terms of it being positive. So Q is the heat flowing into the gas. W is work done. Can't hedge our bets here by just saying work done or work done on/by. We've got to define it as the work done by the gas. So make sure those definitions are learnt very carefully. Easy to throw marks away. Next we've got to calculate the work done by the gas during the process AB. Well, if there's a constant pressure, we can use the relationship that W is P delta V, or more generally we can find the work done by finding the area underneath the line there. In this case the area underneath the line AB is exactly the same as the pressure times a change in volume. The pressure is 60 kilopascals. We mustn't forget the multiplying factors on the sides of the graph, on the axes of the graph. And the change in volume, well, the volume has increased from 50 to 100, so it's 50 times 10 to the minus 3. Again, a multiplying factor here. Those bits cancel. 50 times 60 gives us 3,000 joules. And this will be a positive answer because the gas is expanding, and when gases expand they do work. The temperature at point A and B are 278 and 556 Kelvin respectively, and the amount of gas is 1.3 moles. We're given the formula for the internal energy, U equals 3 over 2 nRT, that's in the data book anyway. And we've got to find the change in internal energy of the gas during that process. So what we can do here is we can use that U is 3 over 2 nR delta T, delta U and delta T. So it's 3 over 2 times 1.3 for the number of moles, 8.31 for the gas constant, and the change of temperature 278 to 556 is 278, but if we want to make sure, we can put that into a bracket there. Now that comes out as just over 4,000 joules, just over 4,500 joules, 4,504, but 4,500 will do. Quick point here, remember that on these diagrams, pressure times volume tells you something about the temperature. And because the pressure at points D and C is exactly the same, but the volume of C is double the volume of D, that means that the temperature of C is double the temperature of D, and the same for B and A. And that's exactly what we got here, that the temperature of B is double the temperature of A. How much work is done during the process BC? Well, there's no area underneath this line, or if you like, there's no change in volume. So therefore, there is no work done. We've got to describe and explain the heat flow during the process BC, and we don't need to do any calculations. But remember what I just said about PV telling us something about the temperature. PV at point B is a higher value than PV at point C, because they both have the same volume, but B is a higher pressure. So that means the temperature at B is higher than the temperature at C. So first thing we can say is that the temperature drops. And that means the internal energy decreases. Now if we use Q equals delta U plus W, We can see here that if W is 0, as we've just written down, then Q is equal to delta U in this case. So the internal energy is decreased. That means Q is negative. And that means heat flows out of the gas. Next, we've got to explain why the change in internal energy over the whole cycle ABCDA is 0. Well, we start off at point A at a certain pressure, volume and temperature, and we finish at point A at the same pressure, volume and temperature. And we know that the internal energy is directly proportional to the temperature. That's from this equation, 3 over 2 nRT here. 3 over 2, n and r are obviously all constants. So if we start at the same pressure, volume and therefore temperature as we finish at, there's no overall change of temperature. Or we return to the same conditions. And therefore delta U will be 0. And it's a very common question, so make sure that you understand that idea, that because we start and finish at the same values of pressure and volume, the temperature at the start is the same as the temperature at the end, and therefore there is no overall change of temperature, and the overall change of internal energy is 0, and that's true for any closed loop. Finally, we've got to calculate the net heat supply to the gas over the cycle ABCDA. So we can use Q equals delta U plus W again. We know that delta U is 0. W, for a closed loop, is the area of that loop. So if we look back at the diagram, we'll find that the area of this loop, remember we can cancel the 10 to the 3 and the 10 to the minus 3 here in our workings, but the area of the loop, it's 20 high and 50 across. Let's put the actual powers in there just to be clear. So it's 20 kilopascals and 50 times 10 to the minus 3 meters cubed, which gives us 1,000 joules of work. Now we're going to decide whether that work is positive or negative. So if we look at the diagram, from A to B there was positive work done because the gas has expanded. We can tell that because the arrow's pointing to the right. And from C to D there's negative work done. We can tell that because the gas is compressing. The arrow's pointing to the left. And there's no work done in either B, C or AD, or DA rather, because those have no area underneath them. The area under AB is greater than the area under CD. So there's more positive work done by the gas from A to B than negative work done on the gas from C to D. So that means that overall this is plus 1,000. So Q equals delta U plus W, so Q is going to be plus 1,000 joules. And that plus means that heat is supplied to the gas, which is what we're asked to find in the question. So the numbers tie up. Thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.